Hello everyone. So today we're going to be going over some rational expressions, some easy kind of explaining it, and then just doing some practice problems. The different multiplication, addition, and then division slash addition, subtraction, and then division slash multiplication. But first, the important thing is learning how to reduce slash simplify, and this is where factoring is really important. So I would that's why it's such a good fundamental skill. So to say like really get your factoring down because it's pretty important. So we're going to reduce this rational expression here. We're just going to factor basically the top and then factor the bottom and then cancel any similar terms, right? So how do we do the first one? Well, this is a trinomial. This is a there's no the coefficient is 1. Pretty simple, right? We go okay. We can do them 12 and -8. Find the two numbers, right? Go, okay, let's do, we know this is negative, right? This is positive. So there's going to be two negative numbers. So I'm not going to do 1 and 12 because obviously there's no way that's going to equal 8, but I'll do 2 and 6 and added together, positive 2 and positive 6 gives us 8. So if I make them negative, right? -2 plus -6 gives us -8. And so these are going to be our two numbers, right? that we're going to use. That's our top one, right? We already had that factored. So we go, okay, our top, x minus 2, funky looking 2, but x minus 6. Okay, now we just need to do the bottom. Okay, so our two numbers are 8 and -6. Kind of a similar thing, right? The multiplication, the sum of our multiplication is a positive number. So it's likely, since we have a negative on this side, it's going to be two negative numbers. I'm not going to do 1 and 8 because obviously that wouldn't make much sense, but I will do, how about 2 and 4, right? -2 times -4. That gives us -6, and two positives or two negatives multiplied together gives us a positive. So 2 and 4, that gives us 8. So those are our two numbers, right? -2, 4. Now we cancel any similar terms. I see two terms that are similar, right, top and bottom. So this is what we're left with. And so our answer, right, when reduced, would be x minus 6 over x minus 4. Okay, so now we have another problem here, but this one is we're going to be adding, right? And so you look at it, and it's basically going to be like adding regular fractions, right? It's just two fractions. Just you have polynomials in them, um, and so it's kind of like, let's say you're trying to add 1/2 and 5/6 or something, right? So we need to find a least common denominator. And when you have polynomials like this, it's just going to be the two combined, right? So you're like, well, how do you find the least common denominator between, x plus 2 and x minus 3? Your least common denominator is just going to be this, right? That's what it's going to be. You're going to see a lot of problems like this up until calculus 2 at least, where you're going to have what's like that you just combine them, like those are your two, right? That's how you get it. And then you just multiply it like you would in regular fractions. And so it's going to come out to this, because it's on the bottom, you're really only going to add this to the top, right? If we have an x2 on the bottom, you're really just going to add the x minus 3 to the top, right? Same thing on here. X minus 3 is on the bottom. We're really just going to add x plus 2 on the top. So it's going to come out to this. This would be our next step of what it looks like. And then, of course, you have to change your denominator. And then you go, okay, well, what do we go from here, right? Well, now we just basically add. So we can expand these and then we'll add, right? And so our top is going to look like this, right? Plus, we expand this, right? That's x3 to x squared. Right, that's what our top looks like. And then our denominator is just going to be the x plus 2 and x minus 3. Right? Now we want to write this in a good, right, like by degree. And also you want to look, can we combine anything, right? Are there any common terms that we can combine? Can't combine anything with x cubed. Can't combine anything with 2x squared because there's no other x squared. Right? You're like, well, there's a 4x here. Yeah, but if this was 4x squared, we could combine the terms. Can't combine anything with 4x because there's nothing else. And then 12 is just 12, right? There's no other number, no other constant that we can subtract or subtract or add. Do that. And so written this like by, I guess the quote unquote correct way, right? It'd be x3 plus 2x squared plus 4x, and we know this is a plus because this is a positive 4x, right? If it was a negative 4x, then we would use a minus 4x, and then minus 12 divided by x plus 2, and then x minus 3, right? And this would be our answer. Okay, so we're gonna have a similar problem, except now we're doing subtraction. Ooh, scary, right? It's literally gonna be basically the exact same thing. However, you're gonna have a negative sign when you're combining the two fractions together instead of a positive, and that can change some things um, when you're simplifying and combining terms, as you'll see. Also, I want to mention then because we don't have it in these problems, but like similar to how we were doing before. Imagine if this was an x squared plus 3x minus 6, right? I don't know, just a trinomial that you can factor. You'd want to factor factor and then do these steps. But because there's nothing to factor here, we're not doing that part, right? And so kind of a similar thing. Okay, what's our LCD, right? Okay, well we know we have polynomials, so we know it's just going to be this, right? X minus 5 and then x plus 4. So when we multiply this to each fraction, right, really the 3 is just going to be 3x minus 5 and then x times x plus 4, right? And so this is what it'll look like. And then we have our new denominator, right? We have to remember that. Minus. And so now we can expand it and then write it down on one thing. And so, it'll look like this here. Okay, right? What's the top? That's x squared, right? X times x is x squared plus 4x. And then we have a minus sign here, so it's going to be minus. Okay, this 3x. And then that's 15, right? Negative 15. And then I'm not going to write it because we can see already, okay, how can we simplify / combine terms here? Well, we had a positive 4x and a negative 3x, right? Those are common terms. We can combine those, right? So just basically 4x minus 3x, which just gives us 1x, which is just the same as x, right? So, when we're rewriting this, it would become, okay, x squared plus x minus 15. And then write our denominator. And this would be our final answer, right? Okay, so here we have our final problem, and now we are dividing, right? Oh my god, division. But you'll come to see, and the reason why I didn't do a multiplication problem is because they are effectively the same thing, right? When you're given something like this and it says to divide, you're gonna end up just multiplying by the reciprocal. So you're gonna flip this, you would flip this, right? This is what you're gonna end up, this one right here. This is what you can end up just flipping, and so it'll become this, right? 2 minus 81 divided by 2x squared plus x minus 1 multiplied. That's, I guess, that's a multiplication. I could use a better sign instead of x because we're dealing with x's, but flip it, right? So x squared plus 10x plus 9 x squared minus x minus, right? So that's all you're doing. And so now you have just a multiplication problem, right? And so if you can do multiplication of these polynomial fractions, these rational expressions, the same thing as division. But I do want to, I wrote it this way with a division sign clearly in the middle. You might see it sometime, I won't completely rewrite it out, but you might see it like this. I don't know, like x divided by like, right? You might see that and you're going to be like, whoa, but just remember, that's the same as division, right? Because that's like writing x 1 over 2, which is, the same as like 1 divided by 2, right? That's the same thing. And so you may see this, right? You may see that and be like, ooh, what does that mean? What do I do here? Just remember, that's really all that is, right? It's just division. And so you're going to do the same thing, except now you're just going to flip it and you can rewrite it yourself into multiplication. So you might see problems like that where it's stacked on top of each other, right? It's like, x divided by x plus 1 over, this example would be, x squared divided by x minus 2. And when they're much longer polynomials, right, when they're, it may be kind of daunting and you're like, oh my god, where do I begin, right? But really just understand that's what it is, because you're going to probably get some problems if your professor is likes to torture his students. Not, I'm joking, but they might write some problems like that. I'm pretty sure, if I remember Calc 2, I think we had stuff that was written like that. Maybe even Calc 1, I can't remember exactly. But like, you're going to see some problems written like that, and so just kind of be aware of that. And that's a little side tangent. Just that way you're not thrown off. You're like, just know that means division, right? And you can rewrite it into multiplication by the reciprocal. Okay, so let's get back to starting our problem. So kind of how I mentioned earlier, right? We need to factor this stuff. I mean, this is a mess, right? So we got to factor. So I'll start off and I'll say, okay, x2, that's a perfect square, right? So we know, just go, okay, x minus 9, x plus 9. That's already our first one done. Nice. And then here, right? So kind of we can do the AC method, right? I don't have a lot of room here, so I'm going to go ahead and just erase this stuff off on the side. Okay. We go, okay, let's do the AC method. So this is for the bottom term, right? For the 2x squared plus x minus 1. So we go, okay, that becomes negative 2. And then just x itself is just 1, right? Because you gotta think, this has a coefficient of 1, right? 1x is the same as just x. In the same way, you might get a trick question. It's like, what is this raised to, right? What is the power of it? It's 1, right? That's just something that you may see. I doubt many professors will have a question that's like that, but just to kind of, for your own sake. Okay, so it's 1, right? So what two numbers? Let's see, what can we do? What's 1 times 1? 1 times 2. Well, this is a negative number, so we know one of them's going to be negative, one's going to be positive, right? And so we go, okay, 2 times negative 1. That gives us negative 2. What's 2 plus negative 1? It's 1. So these are our two numbers. And as mentioned before, with factoring, right, you're going to split them up, and then you're going to go from here. So we're gonna, split up the x, so it would become 2x squared plus 2x minus x minus 1, right? Now we have to factor that by grouping. Go, okay, boom, 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 boom. What can we pull out of here? We can pull out a 2 and an x. What can we pull out of here? We can pull out a -1, right? Because really this is -1x minus 1. And that becomes positive. And this becomes positive. Because we're, got to think we're basically dividing, right? What's -1 divided by -1 and give us a positive 1. Okay, so that now our two things on the bottom here after we factored be 2x minus 1 and x plus 1. Right? And we're still not done because we have this side to do. And I'll rewrite the multiplication symbol. We're still not done because we have this side to do. Now, luckily, they're kind of the same method, right? Finding two numbers look a little easier. Okay, so let's start with this one, right? X squared plus 10x plus 9. Okay, 9 and 10. What two numbers? Well, 1 times 9 is 9. 1 plus 9 is 10. Wow, that was so easy. Sometimes you get lucky like that. Right, we can only hope that all your problems are like that. So let's do the next one, right? X. So negative x, again, -1, and then -90. So I'll do it over here. -90, -1. Oof. This is a little bit more of a tougher one, right? It's kind of like, hold on, wait a minute. These are a big difference. But again, just always start off, be like, okay. Obviously I'm not going to do 1 and 90. I'm not going to do 2 and 45. Until you got to kind of make the two numbers that you're going to be multiplying together a lot closer. So I would say, okay, what about 10 and 9? That gives us 90, but remember, one of them's negative. So what about, if I look here, 10 plus 9 is 19. What if I make one of them negative? What if I make it 10 times -9? That gives us 1. And that's not exactly what I need, but that's close. So what if I do -10 and then 9, right? So -10 times 9 does give us -90. -10 plus 9 does give us -1. So these would be our two numbers here. So x minus 10, x plus 9. Go down a bit. Okay, so this is where we're at right here, this step. Again, cancel terms. So, okay, I see a x plus 1 and x plus 1, x plus 9, x plus 9. And that seems to be, I think, about all we can cancel. If I'm not mistaken. Yes. And so we're going to be -9. Or sorry, x minus 9. X plus 9, because we have it here. Divided by 2x minus 1. And x minus 10. Right, and that would be our final answer. Right, so really with multiplication and division, they're going to end up being the same problem, right? If you're given a division, you just flip and multiply by the reciprocal. And if you're given multiplication, you're already done, right? You're already there. You don't have to do that additional step. And then just remember to factor first, simplify, and then from there, right? So addition and subtraction, on your numerator, you're going to combine terms. Division and multiplication, it's just going to become a multiplication problem. And once you simplify and everything, you're just going to cancel terms out, and then that's what you're going to be left with as your answer. I hope you learned something. I hope you're able to do the practice problems first and kind of be able to get it. If not, when I showed you how to do it, you kind of learned a lot, and you're like, okay, this makes more sense. I hope you have a great day, and I hope you do well.